So I'd like to bring an update to you of our energy harvesting project and what we've been working on with many members of the community and many of the stakeholders and many of the people that are on this call today. So let me start off with just bringing that a report came out this week from in Canada that in June 21, there was actually a law passed by the Canadian government that set Canada on its way to meeting its Paris Accord objectives, and that was to be net zero by 2050. Part of that law was that there had to be plans developed and put in place, and there was reporting requirements, and the first plan was due in 2022, and this week that plan came out. And that plan targets a 40 to 45% reduction below 2005 levels by 2030 and net zero by 2050. Now, you can see the numbers, and a minimum reduction of 283 million tons is required to meet the 2030 target in the 8 years that remain to 2030. Now, that's of interest because you can see in the background or in the other parts there that in the 14 years between 2005 and 2019, emissions were reduced only 9 million tons. So that means that in the next 8 years, we'll have to do 283 million tons of reduction, which means the programs and the movement towards net zero will need to accelerate at a great pace. So we often talk about net zero, and some of the times when we've been doing presentations, the questions comes up, well, how do we achieve net zero? And Peter already talked about the 3 C's of getting on our path to net zero, being conserve, connect, convert. And when we talk about conservation, we're talking about reducing the demand for energy and using energy more effectively. When we're talking about connect, we look at the value of integrated energy networks or district energy to help achieve that goal. And then finally, convert, and that's eliminating the fossil fuel sources. So if we look into further into reduced demand for energy, very simply, it's turn out the lights, walk or bike instead of drive, turn down the thermostat, reduce demand. And as Peter said, that's what the Sweden did in the 70s to reduce their dependence upon Arab oil. But there's also the years past and the tremendous things we've seen with digitization. The use of digital models and modeling artificial intelligence has tremendous potential to reduce energy as reduce energy. And we're going to hear a whole section on that later this morning. Energy retrofits, those are foundational. We've been talking about those for many years, either putting more insulation into our homes, changing windows, putting new cladding, but using less energy by needing less, by protecting us from the elements. The other thing that's big in this area is lower temperature heating systems. By going to lower temperatures, getting the temperature of the heating medium closer to the house temperatures, we get higher performance. And we've already seen that as we've moved from steam heating in some buildings to hot water to now to warm water, and that's reducing the temperatures. And this is very important because we're going to talk a little bit later about heat pumps and the electrification of heating. And in order to use those heat pumps effectively, we need to get to lower temperatures. So then once we've reduced our need for energy, we need to get the most out of every joule. And what does that mean? It means we have to increase our efficiency. In the short term, we need to have everyone using high efficiency condensing furnaces if they're burning natural gas. We need to start the use of more of heat pumps, and we're going to see more heat pumps come into the world. We have to, and this is the next point is something that we've looked at and spent lots of time on, and what this project is really about is energy sharing and harvesting. Studies from 2013, and you can see the pie chart, show that of energy that we use, 66% is wasted in Canada and only 34% is used. So this just shows tremendous potential for sharing and harvesting and getting the used portion up and the wasted portion less. The other thing that's very important in this is seasonal storage. Because of our climate and in the north where we are, it's cold in the winter, hot in the summer. So when we talk about sharing and using the heat from cooling, we need to put it somewhere because we have to harvest it in the summer and then use it in the winter. And this concept of seasonal storage is becoming very, very important and will allow us to use less fossil fuel to heat. And then the next part is connect. And we call these integrated energy networks, and really they're district energy networks or integrated community energy, but they're really highways. They're thermal networks, and what they do is they connect buildings. And they're just the highway, they're the pipelines that connect the buildings. And what they do is their major purpose, or their big important part, is that they allow us to future-proof our system. So that if we want to change the heating source in the city, we don't have to change furnaces and boilers in each building. What we only need to do is change it at a single source that provides the heat to those buildings through a thermal network. So that's very important that we get into the idea of connection. So, but there's also other benefits other than that future proofing that go with connection. Not all buildings peak at the same time, so that we don't have to have the levels of redundancy. We get better resiliency because we have more equipment that can supply heating and cooling. Equipment becomes operated at its duty point, leading to higher efficiency, higher reliability, and all those go together to lower GHG emissions. The other thing that's important is networks and consolidating heating and cooling for a city allow a cheaper way to decarbonize. And there's a City of Toronto study that highlights this, that this is a very important thing that we should be looking at, because what it does is it provides a way to decarbonize, and a way to decarbonize economically. And what we're really looking at is the integration of data networks, and you'll see that in the next talk, but with the thermal networks as we pipe hot water around the city and chilled water around the city, and also the distributed energy resources and the electricity. There's no doubt that we are going to be doing more solar and solar PV and renewable power, but we need to integrate all these things together into an integrated energy network to make the best use of each one. Then we get to the eliminating the fossil fuels. And we can, by getting rid of fossil fuels, we can go to all sorts of renewable sources. Everyone's probably heard of geothermal, drilling boreholes in the ground and using the ground's heat for both heating and cooling. Solar, thermal solar, where the sun's power is used to heat hot water that is then used to heat buildings, or the solar photovoltaics, where the sun shines on panels and electricity is made. Renewable natural gas, and Hamilton's a leader in renewable natural gas from its wastewater treatment plant. Hydrogen. We all hear about hydrogen and how hydrogen is the new fuel of Canada, and will be used and will supplant supplant natural gas. We also have heard of biomass, and biomass is wood pellets, any plant matter. And we know that certain power plants have now moved over to running biomass. And the important one that we see is industrial residual heat. And we see this as a tremendous resource. And this picture here is just some of the work that we've done with McMaster Engineering on their ice harvest projects, which features all of this: sharing, harvesting, the use of industrial residual heat. And we've been very fortunate to have worked with McMaster Engineering for several years and on their research project, and they've taught us a lot about the way that we can move forward to decarbonize and be more efficient. And then the last one that we often talk about as a key to eliminating fossil fuels is electrification. And electrification is sort of that just standby. That's the one that everyone leans to. When we think of how we're going to electrify transportation, we think of Teslas and we think of batteries and we think of electric vehicles. And that we just take that for granted. And often now when we talk about electrification of heating, we think of heat pumps and air source heat pumps and just switching to electricity, and it'll be just a simple switch and that will move over. However, as Peter mentioned, heating is the elephant in the room. There's a few things that we look at when we talk about electrification, and there's some concerns. One is the cost, and in the graph here, you can see we plotted what we think of what electricity prices are compared to natural gas prices, and this is on a per gigajoule basis. And there's an argument to be made that different efficiencies will move the lines around. But you can clearly see electricity is more expensive, even in 2030, than natural gas. And we're going to have to deal with the extra costs that electrification deals with us. The other thing we need to look at is supply. So in 2017, according to Canada's energy regulator, electricity made up 16% of the 3,035 petajoules of energy that Ontario used. And a petajoule, I had to look up to find out what it is, but a petajoule is 10 to the 15th joules. So a really big number. But anyway, of that, refined petroleum made up 48%, natural gas was 28%, Other was 8%, and electricity was 16%. Now, if we look at electrifying natural or the home heating, we see that natural gas or residential heating, natural gas would fall to 18% and electricity would grow to 26%. Now, if we look at, which is almost doubling the electricity that we used in 2017. Now, if we look at further, if we look at electrification of transportation, we see that electricity would go up to 55%. So we've almost 3.5 times increased the need for electricity. And this is on an annual demand basis. But then there's the idea, or then there's the concept of instantaneous demand. And this is where our northern climate comes into play. And we don't, and if we were to look at the use of natural gas over the season, we'd see that most natural gas is used in the winter because it's related to heating. So maximum heating is required in the December to February timeframe. And when we think of the December to February timeframe, what we find is that a lot of the electric heating solutions, the air source heat pumps, are at their least efficient at that point in time. Also, we know that because of daylight hours, solar PV generation is at the least in the winter. So we have the highest demand and the least amount of solar and the lowest efficiency of many of our electrification of heating items. So we really need to take a deep look at this. We do know that electrification will be the key to decarbonization in Ontario because of our green grid, but we believe that electrification in conjunction with thermal networks will be the real key to doing this to the decarbonization to our decarbonization in both an economic and practical manner. So now, looking at our project to do this, and really what is our project? It's a net zero energy distribution system to heat buildings with industrial residual heat. And that's what we're really looking at. Looking, as Jeff mentioned, all that heat that's going into the atmosphere on the Bayfront and use it to heat homes and buildings in Hamilton and to allow us to turn off natural gas and get away from fossil fuels. And this started, as Paul mentioned, on some work that the Chamber did in cooperation with TAF, the Atmospheric Fund. And really where we are, and what we've talked about in the past sessions, is we're really in this stage of our project, where we're shaping the project for success and funding. And that'll lead to a feasibility study that we're hopeful to get underway this summer. And out of that feasibility study will come ownership, governance, and financing of a final project, leading to detailed design and phased implementation. And this is really where our interest lies. We're doing all this work and putting this effort in, not to create a lot of paper, not to put consultants to work building studies. What we're in it for is to build the product, build the system, and use it use it in our systems and other systems, expand our systems, but use it to decarbonize heating in Hamilton. So that's our project, and I want to talk a little bit more about where we are right now. So let's go back, take a step backwards first, is it began with the opportunity identified. And this work was done with the Atmospheric Fund and the Hamilton Chamber of Commerce. And this report came out in June or in early 2021. But the keys for this was the industrial residual heat that was estimated was 4 million gigajoules per year. I would tell you how many gigajoules there are in a petajoule, but that's quite beyond my thinking right at this point. But everybody, that's a good homework assignment for everyone. But what it was enough heat to heat 45,000 homes for a year. And that would reduce our carbon footprint by the equivalent of 200,000 tons of CO2. So that's where we started with. And then for us as a district energy provider, what did the report really show to us? It showed us the opportunity for energy sharing and making the most out of every joule and utilizing industrial residual heat that was going to the atmosphere, utilize heat from cooling. Many industrial processes make use of cooling towers to cool water for their processes. That's just heat going into the atmosphere. And altogether, and to sum it up, it's an opportunity to minimize waste. So how would we do this? What would we look at? Well, right now, to heat buildings in Hamilton, we have a hot water network. And our hot water network is about 100 degrees centigrade, just below boiling. So we would look at how could we get a stream that would be the same as that, the same as what we presently use, and use it to supplement our existing hot water system. And it also allows us to cool through absorption cooling. So that technology, not only can you heat with it, you can cool with it. But we also looked at a low temperature network, a warm water network, and this would be the water coming from the cooling towers. And what this does is it sets us up as an alternative to geo-exchange, because what we're looking at in a geo-exchange is that out of the boreholes in the ground, we'd be quite happy to get 30-degree water and then use a heat pump to boost it up to temperatures that can be used to heat a building. But why would we want, well, if we could get this warm water stream and have it year round, why would we need to worry about drilling boreholes and setting up geofields and balancing them? We could just use this resource. So that's what, as a district energy operator, this is what interests us and what we're moving ahead with. So we looked at this independent project analysis company, and we talked about shaping and how project shaping is tantamount to project success. And what those lessons from them were is that complexity is rarely technical and must be managed. You need clear business objectives. You have to involve, educate, and align stakeholders. And that's what we've been doing through these series, through talking today, and through the many meetings we've had. You need a project governance structure with stage gates. What you need to do is make sure that every part of your project is value adding, and you have to engage your project sponsors. And you have to communicate. And so what we've done is we've tried to do all this. Here's our notional thermal network. You can see how we're looking at bringing heat out of the industrial bayfront and into the downtown. And you look at this distance, and I think it's probably in the 4 to 5 kilometer range. And a lot of people say, well, can you really do that? And then that's been one of the good benefits of having Peter and the European existence or experience come forward. So in Stockholm, Sweden, their district energy network spans 70 kilometers. If we were to span 70 kilometers, we'd be taking industrial residual heat into downtown Toronto and thinking that was possible. Here, this is entirely possible, and really the Europeans would look at this and almost laugh that we have concerns over this. But anyway, so this is our project shaping. So what have we learned from the project shaping? What have we learned from our stakeholders and going forward? Well, what we've learned is what defines success to our stakeholders. What has to be met in this project to say we've had a successful project? Well, we need to have an innovative net zero carbon solution. We have to future proof. We have to make that big step and move forward and get to that. We don't want to go part way. We need to make this giant leap. We need a solution that's resilient, dependable, secure, and utility grade. When we walk into our rooms and flip the light switch, we expect the lights to come on. When we're on a system that's providing heat, we expect it to provide heat. Those are things that we don't want to ever think about, but that's what we have. That's the kind of solution that we need. A solution would have to, a lot of our stakeholders and a lot of the people we have talked to are already into big ways to decarbonize. So anything that we do has to be complementary and incremental to their present efforts. They don't want to have us come along and say, no, you don't have to do all this that you've been working on. You need to do this. They want a solution that's complementary and incremental and just builds on what the work they're presently doing. We know that Hamilton is growing, and Hamilton's downtown is not going to look the same in 10 years as it does today. There's going to be tremendous amounts of growth. And so whatever we're doing has to be an enabler for that growth. How does it help that growth? Because it's going to happen, and what we need is an answer that doesn't stress the city any more than what it is today, but actually helps that growth occur. We want it to be a low risk solution. We want to de-risk the solution. So it has to be managed and phased. Most importantly, there has to be business cases for it. There has to be a business case for the residual heat collection and use. These are this we heard strongly from the people that would supply us the heat. There has to be this business case. There has to be value received for residual heat supply. be it in dollars, be it in carbon credits, be it in cold water. Some of the people we've talked to look at their cooling towers, and in hot, humid summer days, they have troubles getting back cold enough water to help their processes. So one of the things they look at is how could they get colder water, because that will drive their process efficiency. And there has to be value for the energy. So value received is a very big important and has to be factored in. The energy distribution system needs to be an independent, commercially viable business. It has to stand on its own 2 feet. It has to have long-term viability, and it has to be designed that way. And the system has to assume the role of as an energy distributor. We heard this loud and clear from our industrial partners. The residual heat suppliers don't want to be responsible to the users. They don't want to talk to the apartment building that there isn't any heat. What they want to do is supply their heat to a system, and then that system has the backups and the necessary infrastructure so that they are responsible to the users. So those are all the things that we've learned from our stakeholder involvement and our discussions to date. And these are the things that we're going to take forward into our feasibility study. And we'll make sure that these are addressed in our feasibility study, and that we end up with a study and a project that's successful to everyone. So where do we stand on this? Well, we've been busy trying to get funding in place. Well, HCE, we're committed to funding. This is important to us. We've reached out to the FCM, the Federation of Canadian Municipalities, and they have something that's called a Green Municipal Fund. We've had a pre-application accepted, and our full application is in progress. We're talking to the atmospheric fund that were so important in getting the opportunity study done. And we've talked to them, and they've invited us to apply for a grant. So we're in process of doing that right now. Enbridge, our local natural gas distributor. Well, they're an energy distributor, and they see the value in this. And we're in the final throes of putting together a funding agreement with them. And we think this is important because Enbridge is interested in the future. We're interested in the future and having them along as a valued partner. Our industry partners, we're in discussion with. And our demand side partners, we're in discussion with, and we're working on that. But we hope to wind this up very shortly and have the monies and be able to go and get this feasibility study started by the summer of this year. So in closing, why are we doing this? Well, we throw out some numbers. So right now, our downtown district energy system services about 2.5 million square feet of industrial, commercial, residential buildings. And our carbon footprint is about 6,000 tons of CO2 per year. And if you remember back what the study, the TAF and the chamber studies gave as potential, it talked about 200,000 tons of carbon could be offset. Well, if we take that 200,000 ton number, we say, well, the 6,000 can be met very easily. But not only can that 2.5 million square feet be decarbonized, if we multiply just doing a simple factoring, we could enable another 80 million square feet of buildings in Lower Hamilton to be carbon neutral. And this is very important because, as Peter mentioned, and we all know, heating is the elephant in the room when it comes to decarbonization. People talk about electrical vehicles, they talk about solar, they talk about batteries, they talk about hydrogen. But 40% of our GHG emissions, our carbon emissions, come from residential heating or from building heating. And we need to address this if we're going to decarbonize.